So I don't have time for my cork jokes then, no? Okay, so I have to move on from that. So basically, what I'm going to talk about is, we've heard about analytics. We've heard about analytics giving us insights. Things like, alerts. We've seen alerts from if there's something wrong with your system, that you get alerts to say, go and look at this and whatever. But one of the things that we find problems with, and it seems to be quite a large problem, is the actual data quality itself, and like having dirty data. So you might get data that's misrepresented, it might be missing and stuff like that. So that's kind of what I'm going to talk about here. So there's an explosion in data, like Claire was talking about the Internet of Things. At the moment, we're kind of overwhelmed with the amount of data. We're getting tons of data from different devices, different systems, and we've got to handle all that data. And this is where big data comes from. We're getting this massive influx of data, and how do we go through it? How do we sort it? And how do we provide insights out of that data? On its own, it doesn't really tell us much, but combined together, it tells us a lot. So we're kind of operating here in the refrigeration on the Internet of Things space, and you can see that the growth rate on this is phenomenal. Every 2 years, it's doubling. So it's just getting bigger and bigger, and we need to kind of embrace it and start using it. The data itself comes in two different ways. It's the structured data and unstructured data. So structured data would be where you have, say, an Excel spreadsheet, and it has columns, and a column says temperature and date, and then the data is filled into those, similar to a relational database. So that's very easy data to work with. You know what the data is, you know what the values are, you go and use it. Unstructured data is more like the opposite of structured data. So it's things like text, videos, photos, and stuff like that. So it's a bit harder to manage. So fortunately, we're working in the structured data on refrigeration, so that solves all those problems. So in regards to refrigeration then, there's just a couple of, categories of data that we've been dealing with. One is the refrigeration parametric data. So this would be data like temperature sensors and so on. So it's data that tends to have a value, it goes up, it goes down, it moves around a little bit. Then we have meter data. So meter data is the opposite. It's where it's kind of constantly aggregating. So you'd have like a meter reading, like the meter in your house for electricity. It's constantly going up and up and up and up. So to get a value of it, you've got to take a reading at one point in time and a reading at another point in time, and then get the difference in the value. And then we have weather data. So we have, sites will have their own weather stations, or you might get regional data. So that affects refrigeration. We've seen from Tesco that you can see seasonal changes in the performance of the refrigeration units. So with regards to data and bad data and so on, there's a couple of categories here that we throw on the data classification. So we have data outage. This is where you have sensors and basically the sensor's not reporting. So there can be a number of reasons why that happens. The sensor could be dead, the wire might be cut, somebody pulled it, or the network infrastructure could be down. We have data intermittency. So this again can be network problems where sometimes it's reporting. The sensor's working fine, but sometimes it reports, sometimes it doesn't report. We have things like data drift. So this is where, for example, you might have a preventive maintenance thing where a sensor is slowly going out of calibration. And these are kind of hard things to detect. How do you know when it's slightly going out? Is there something actually happening, or is it the sensor that's causing the problem? So detecting that is kind of a fairly difficult thing to do. And then we have data abnormalities. So this is just kind of noisy data, corrupt data from databases and so on, sensor failures, and sensor replacement and so on. There's a couple of examples here that I have in the next few slides of data. So this one here is a scaling factor. So here you could be looking at your data and you're saying, oh, that's great, everything's running fine, I'm really efficient and so on. You could have other metrics that are using this data. But in fact, there was a problem with the data. Oops, I'm not going too far forward there. Doesn't go backwards, is it? There we go. There's a problem here where the scaling factors were wrong. So it has a reading, it has a pulse reading from the meter, and you multiply that by a kilowatt hour reading, and it was the wrong scaling factor. So what that means is then you see a big jump in the data. It looks like that, hang on, what's going on here? Have we some problem? There's alerts going off everywhere, but in fact it's a data quality issue. Another example here would be where we use virtual meters. So a virtual meter would be, we have two submeters. We don't actually have an upper level meter going down, so we create this virtual meter, and we'd say that the 2 meters combined give you this virtual reading. But what can happen is 1 meter goes down, you might have analytics running off the virtual meter, and it looks like, and particularly if they're not evenly balanced, if one maybe is only 10% and the other one is 90%, it looks like you've got a small little dip in your usage. But in fact you haven't, you have a problem there. So trying to detect these problems is quite important. This is a kind of more complicated slide here. So if you just draw your attention to the top piece here, so this is where we're looking at a meter reading. So this is where it's an aggregated value that's going up and up. And if you look at this data here, you might say, oh, that's really interesting. At first glance, you say, yeah, not much usage here. It's kind of going up. You can see 3 steps here on the data. So you can say it looks like in June of 2014, we're using a lot more energy. So all the alerts go off and say, yeah, we're using more energy, quick, everybody run around and try and do stuff. But in fact, if we combine that with other dimensions within the data, we see that actually there's no problem at all actually happening here. So let's just look at the first one here. So this one here is the time intervals. So the thing about meter data is that you're sampling from one time to the next time and getting the difference. So depending on how that time variance changes, it looks like the consumption is higher or lower. Now you might say, oh, we don't have that problem. I set the system up and I put in 15 minutes. So now when I display anything or put analytics, I'm going to use 15 minutes. But when you have a lot of sensors, you have a lot of infrastructure, you may not be reporting every 15 minutes. You might get some problems in the network, and the sensor might go down and so on. So if you actually look at this data here, you can see that the intervals between them actually correlate directly with these spikes that we have in the data. So we can see that actually when there's a bigger gap in the sampling time, it looks like the energy has gone up. So in fact, what we could do is before we go and actually throw alerts out and get everybody panicking, we can look at this level of analytics and say, well, hang on a minute, we see a correlation here. Hold off for the moment, okay? But then you might go back and say, well, hang on, we have this big shift here. There's definitely a shift here. But if you look at the bottom here, we can see again, right? This is looking at a different area of it. This is where we look at the number of points that have been recorded during the day. So it's a little bit, it's more of a daily basis type of a thing. We can see that the sample rate here has gone down. So if we think about it, if we were reporting every 15 minutes and we were using 100 kilowatts, if you report every half an hour, it's 200 kilowatts. So you can see that because the sampling rate went down, you can see this correlation here with this and this. Again, there's no actual problem with this particular setup. So what we're trying to do is we're trying to say we want to use analytics, but we want to use them sensibly. We want to say, don't give alerts, don't give false alerts. Nobody wants the boy who cried wolf because you get sick of it. You get alerts in, it could be a real alert, and you say, listen, I get 20 of these a day. I'm not going to bother looking at it. So it has to be good quality data that you get in order to believe what you're seeing. So we're working in this area, of course, and we've basically set up 4 different categories, similar to the slide that I showed you earlier on. So we have this data outage. So this is just basically where the sensor's not reporting. So that's fairly easy enough to detect. We have data intermittent, data point intermittency, and this is a change in the data frequency and so on. So we try and detect that, and we have algorithms and so on that'll do that. The data point based drift, again, this is a bit more complicated. It's where we're looking over time and we're looking at the slight drift in a sensor. So it could be like a temperature sensor that is out of calibration, and maybe over a month it drops up by 1 degree, another degree, and you may not see it over time. So it's very hard to detect that. Looking on its own, it could be that your store is increasing in temperature, unless you're getting complaints from customers and all that. You may not know, but there's other ways of looking at this by maybe looking in comparison to other sensors and saying, well, hang on, these other sensors aren't drifting, so maybe this is a sensor drift rather than an actual increase in temperature. And then there's the abnormal reporting, and that's just funny behavior that's going on within the sensor. So this is an example from one of the systems we have, and what we've done actually is we've set it up as an RSS feed, because particularly when we were starting off at first, we were getting all these false alerts. So we didn't want to crowd up our texts or our email system. So in Outlook or in Lotus Notes that we use is an RSS feed reader. So basically all you do is you subscribe to sensors that you're interested in. So I'm interested in certain sensors, Niall is interested in other sensors. Charity's not interested in any sensors. So we just subscribe to these, and we can look on a daily basis. You can set how often it refreshes and all that sort of stuff. So you can control how many messages you get. This is the type of output we get then. So this example here is a data outage. So it says that we've seen that there's the sensor hasn't reported in the last 24 hours. Now, we don't look at the last half an hour so we can instantly react, because what happens is sometimes you get a glitch in the system and maybe it doesn't report. So we look over the last 24 hours and it gives us the last date that it actually reported. So this is quite useful. It means we can go out there and address it. And in fact, we see that with our temperature sensors. We have temperature sensors in our office across the way, and they're underneath the desk and they're wired, and people are hitting off them all the time, So I go in and say, oh yeah, that's that sensor, go down and just plug it back in. So it's fine. The next one then is non-normal reporting frequency. So in here you can see, this is on the bottom here we have the sample interval. So just saying, I'm sampling now, the next time, the next time, the next time. Which we can see that the interval here has spiked up over an upper control limit. So we can say, like, we expect this to go every 15 minutes. If it goes over, say, what have I got there, 30 minutes, let me know, because maybe there's something wrong with this particular system, or we need to catch it, we can catch it fairly early. Next one then is sensor drift. I said this one is a bit more complicated to capture. And again, we detect that, and we look at other sensors as well. So we don't look at the sensor in isolation, because it's very, very difficult to do it in isolation. So we look at that with other sensors and so on, and try and detect that drift. The last one, I know Niall is trying to push me on here with time. Actually, one of the other things that we have as well, just on the data and data outage, another problem that we came across was when you have missing data or data that's bad, what do you do with the gaps? Because you might have analytics that require to look back on this data, and you don't want to have blanks in it, because then you're missing huge chunks of information and insights from that period. So we look at things like, how do we clean the data? So if you have, say, meter data and you're missing, say, a 15-minute period, you might say, well, okay, I have a reading here, I'll just do a straightforward interpolation and say it's the midpoint. But supposing it's over a month, supposing you're missing data in a month because the alerting wasn't working, or you were ignoring the alerting, you may not want to just do, well, here's the reading here, here's the reading. Every day it's just being incrementally increasing. You might want to look at, well, hang on, I'm going to look at a previous month or a previous month from the same year and use the profile of that to use the interpolation. So it becomes more meaningful. So in the evenings, we don't use as much power, and in the days, we use a lot more power. With temperature sensors, is even probably a little bit more complicated. In that case, or any other type of a sensor where it's the ratios kind of vary slightly, it's very hard. You can't really interpolate on the sensor itself. So what you might need to do is look at sensors that are sitting around the area and do some sort of 3D interpolation between those sensors to give you a value for that particular sensor that you're missing. So these are the types of things you need to do for cleaning data. So I guess the thing to just drive home there is that, you've got to trust the data. If you don't trust the data, you don't trust the stuff that it's telling you. You don't trust the alerts, you don't act on the alerts. So if you can really trust that data, you understand that it's being evaluated, when it gives you an alert, it really is an alert, then you're going to use these systems. And that's really it. Okay.
Thanks, Ray.
Fast.
Okay, so we're just